Hey everybody, Ms. Dietrich here. We're going to be doing lesson 4.6, which is on finding unit rates. And our essential question that we're going to be answering today is how can you use unit rates to make comparisons? Let's take a look at this first question. The starfish, or carambola, is the fruit of a tree that is native to Indonesia, India, and Sri Lanka. Slices of the fruit are in the shape of a 5-pointed star. Lara paid $9.60 for 16 ounces of starfruit. Find the price of 1 ounce of starfruit. Whenever you see these kinds of questions where we are looking for the unit rate, I'm going to suggest that we set up proportions. So we're talking about dollars and we're talking about ounces. So I'd like to always label the side. And how much money we're talking about? $9.60 for 16 ounces. Now we want to know how much is it? What's the dollar amount for 1 ounce? So here's our proportion. Now there's a couple ways you might consider solving this. One way is to recognize the idea that we can just divide 16. 16 divided by 16 will give us 1. So really in the end, what do we have to do? We have to take this number and divide it by 16, which is really what this slash means, right? Doesn't this slash mean divide? If we just look at this by itself, that means $9.60 divided by 16. So that's what we're going to do. We're going to divide 960 by 16. So let's set up the algorithm over here. And we'll show the divisor over here. We'll put the decimal in the quotient right away so we don't forget. And you want to think about your multiples of 16. 16 will not go into 9, so we'll put a 0 there to hold our place. But you want to think about how many times 16 might go into 96. Now, whenever you have no idea and you're just completely in the weeds on what factor to use, it's always recommended that you start out with a 5. So let's try that. 16 times 5. This would give us the 30. Here we have the 5, and the 3 more would be 80. So if you're not sure if that's going to work, then you would also want to try the 6. Here we get the 36. 6 plus 3 would be 96. So that works out to be exactly what we're looking for, right? So let's put the 6 here and the 96 here. Subtract. We get nothing left over. We'll bring down this 0. And 16 goes into that 0 times. All right, so when we're talking about how much money that is, that's 60 cents per 1 ounce of starfruit. So by the way, when they want it as a unit rate, they really do want you to put the, per 1 ounce and just write it like that. Because if you just put the the 60 cents, that's not a unit rate. A unit rate always has a 1 underneath it, or it's always comparing the 2 units. By the way, if they don't have the word 1 here and they just write ounces, then it's understood to be 1 ounce. All right, let's take a look at another question. During migration, a hummingbird can fly 210 miles in 7 hours, and a goose can fly 165 miles in 3 hours. Which bird flies at a faster rate? All right, so always separate your workspace whenever they give you something like this, because they're talking about 2 different birds. So let's label this side of our workspace for the hummingbird and the other side for the goose. And let's look at the numbers they give us. So the hummingbird, they give us 210 miles in 7 hours. So the units that we're talking about here are miles and hours. So let's throw that on the side. And whenever we're looking for a unit rate, we want to know how far are they going in 1 hour. So what's the miles per 1 hour that the hummingbird is flying? Now for the goose, we're going to kind of do the same thing. We'll look at the particulars in the problem. They're saying that it can fly 165 miles in 3 hours. So again, we're still talking about miles and hours, which is good because sometimes it's tricky when they throw in minutes. All right, so we'll put that there. And we still want to know how many miles is that flying in 1 hour. That's what unit rate means. All right, so this is mental math. Whoops. It's mental math because 21 and 7 are compatible. So if we just do 21 divided by 7, that's going to give us 3, and then we just have to bring down this 0. So basically, what did we do? If we're going to go across, we can look at it this way. Oops, let me move that yellow box out of the way. Actually, let's delete it so it's out of view. So what did we really do? We did this divided by 7, and we did this divided by 7. 7 divided by 7 is 1. This divided by 7, we got 30. So it goes 30 miles per 1 hour. So really how we should probably write this, instead of just putting that, let's actually write it out. 30 miles per, we use the slash, per 1 hour. So that's the unit rate for the hummingbird. Now let's look at the unit rate for the goose. So again, we have to divide by 3. Since 3 divided by 3 is going to give us that 1, we have to do 165 divided by 3 to get this number. So let's do, this is probably not mental math for most folks, so let's do the algorithm off to the side. And maybe I should give myself a little more room. A little more room. All right, there we go. So 3 will not go into 1, but it will go into 16 5 times. And we'll get the 15. Subtract, get the 1 left over. Bring this down. This goes into this 5 times. And it works out evenly at that point. All right, so when we write it as a unit rate, then we're talking about the goose flying 55 miles per 1 hour. Miles per 1 hour. All right, by the way, sometimes you might see it written instead of the slash. If you ever see the word per instead, this word is kind of the equivalent of this symbol. Per means divide. All right, but that's just another little side note. All right, so now we actually have to answer the question, because just you have all this nice work, but you got to actually analyze it and figure out which bird flies at a faster rate. Now, how do you know that something's flying at a faster rate? What would be true about the miles per hour? So this is going 30 miles per hour. This is going 55 miles per hour. This is farther in 1 hour than this. So that bird is flying the faster rate. So if there was that one answer space where you had to put the name of a bird, you would put the goose. And then if you needed to explain, if it said something like explain your answer, you might say because the goose is flying at 55 miles per hour, which is greater than 30 miles per hour. All right, let's take a look at another example. A 64-ounce bottle of apple juice costs $5.76. A 15-ounce bottle of apple juice costs $1.80. Which item costs less per ounce? So again, we're doing a comparison of two different things. Whenever you're comparing two different things, the recommendation is to draw a line down the center of your workspace and kind of figure out how you want to label it. So we have the, what we might call that larger container. So we'll just call it the 64-ounce container. And then we're also looking at the 15-ounce container. And we're trying to figure out which one is going to be less per ounce. All right, when we set up our proportions, we put in our fraction bar. And we're always talking, whenever we're dealing with unit rate, right, or price, we're talking about how many dollars per ounce, right? So they're talking about dollars in ounces. So here we have a 64-ounce costs $5.76 for 64 ounces. And if we kind of set up a proportion over here, the smaller container, it costs $1.80, and you get 15 ounces for that. So our labels here are dollars and ounces. Now, in both cases, we want to know how much is it for 1 ounce per ounce, right? Per ounce means 1 ounce. So we need to find that for both. All right, so what's the math behind it? The math behind it is to recognize that really what are we doing if we're using proportional reasoning? We really have to find this divided by this. Why? Because 64 divided by 64 is 1. So we have to find this divided by 64 to get the answer. Over here, divide by 15 to get that. Divide by 15 to get how much it is per ounce. Now, in the interest of saving a little bit of time, I'm going to use the calculator. So let's take out the calculator. I'm going to hit the clear button. And let's work on this calculation. So that's 5 76/100 divided by 64. And we get this. So let's write that number down. 9 cents per 1 ounce. And let's do the other one. So the other one is, let's see, I'm forgetting the number already. It's $1.80, which I'm just going to put in 1.8 because that's equal in the interest of saving time, divided by 15. And we get 12 cents per 1 ounce. All right, so again, 9 cents per 1 ounce, 12 cents per 1 ounce. So what costs less, and how do you know it costs less? It costs less when you know that you're spending less money for that 1 ounce. So this is less money than this. So if there's an answer space that we got to put something on it, we're going to write that the 64 ounce costs less per ounce. And sometimes they want you to explain. So if they want you to explain, then you would actually state what you got. 9 cents per ounce is less than 12 cents per ounce. All right, so let's look at another question. Let's look at this one. At a grocery store, a dozen eggs costs $1.20. At another store, 1.5 dozen eggs costs $2.16. Which is the better buy? Whenever you're comparing two things, you want to separate your workspace and kind of come up with some sort of a label. So we'll call this one the first grocery store, where they sell it by the dozen, right? So that's, you get the 12 eggs. And at the other, we'll call this the second store. They sell them not by the dozen, by a dozen and a half. So by the way, if you didn't know, a dozen is equal to 12. So a half a dozen would be half of 12, which is 6. And if you add 12 plus 6, that gives you 18 eggs that we're talking about, right? 18 eggs is equal to this 1.5 dozen. All right, so let's set up our proportions for both situations so we can analyze which is cheaper and which is the better buy. All right, so here, when we think about how much are you paying per 1 egg, right? So we're talking about per egg. The first store, we're buying our dozen for $1.20. And you're getting the 12 eggs, because that's what a dozen is. And at the other store, you're paying $2.16, but you're getting 18 eggs for that price. So again, the bottom, we're talking about eggs. All right, so in both cases, we want to know what's the dollar amount that we're paying for 1 egg. You need that for both, for 1 egg. All right, so again, let's use the calculator to kind of speed things up. So what are we really doing? We're going to be dividing both of these numbers by 12, because 12 divided by 12 is 1. So let's find this divided by 12. Now, really, that's mental math. You should be able to do that in your head. But let's just review how to use calculator. So we have $1.20, which is the same thing as 1.2. And if we divide that by 12, then we get the 10 cents, right? 10 cents per egg. And if we look at the other example, we're dividing both of these by 18. This divided by 18 gives us that 1 egg. So we're going to do this divided by 18 to get the cost for that 1 egg. So let's get the calculator out again. Let's move that up so we can use the whole thing here. 2.16 divided by 18 gives us 12 cents per egg. Now, how do you know something's a better buy? It's when you get, it costs less for the item, right? It means it's a better buy. So this is the better buy right here. 10 cents per egg is better than 12 cents per egg. So we're going to say, the dozen is the better buy. Dozen eggs is the better buy. And we have our evidence with our work. All right, a little tough to write with a mouse, but I think I'm doing all right. All right, let's take a look at some of these more simple questions where you just have to find the unit rate. All right, so the directions are missing here, but basically they're asking us to find the unit rate. Now, when they want the unit rate, you want to set up your proportion. You want to look at your units. We're talking about miles and gallons, so we'll put the M over here and the G here. And we're talking about 72 miles on 4 gallons of gas. So if we're looking for that unit rate, we want to know how many miles on 1 gallon of gas. So how do we do this? We're going to divide by 4. Since 4 divided by 4 gives us the 1, we're going to do 72 divided by 4 to get the answer. So 72 divided by 4 gives us that 18. So what would we write on the answer space? We would write 18 miles per 1 gallon. Per 1 gallon. Now remember, if you ever see it written like this, 18 miles per gallon, have you ever seen that? Maybe at the gas station or at the car dealership. This means the same thing as this. But in the math world, math teachers would rather you write it this way than write it this way, because when you write it this way, it doesn't really look like a unit rate. When you write it this way, it's very clear that we're talking about a unit rate. All right, we'll look for a few more examples here, and then if you need more instruction, there's probably going to be another video that'll be separate from this one. So here we have Dean paid $27 for 4 movie tickets. We want to know the unit rate. In other words, how much per movie ticket for 1 movie ticket. When we set up our proportion, we are talking about money and we're talking about tickets. So it's $27 for 4 movie tickets. We want to know how much money or how many dollars is it for 1 movie ticket. So once again, what are we doing here? We're dividing by this denominator, which in this case is 4. We're dividing both by 4. Now this isn't going to work out evenly, right? That's just not going to work out evenly. So we're going to have to talk about some change there. 27 divided by 4. And I don't have access to the equal thing. Let me hit that. And we get $6.75. So we would write $6.75 per 1 ticket. To write it out as a unit rate, there has to be several elements to it. You need the 2 units need to be obvious, and you need 1 to be your denominator, and you need to calculate the numerator correctly. All right, so let's look at this one. Amy and May have to read Bud Not Buddy for a class. By the way, good book if you haven't read it. Amy reads 20 pages in 2 days. May reads 35 pages in 3 days. Who reads at a faster rate? So again, when you're comparing 2 people, you want to divide up your workspace so you don't get your stuff confused. We're talking about Amy. We're talking about May. Amy reads 20 pages in 2 days. So when we're setting this up, we're dealing with pages and days. Pages and days. And we're going to have that same situation for May. She's going to read a certain number of pages in a certain number of days. But let's get back to Amy. For Amy, it's 20 pages in 2 days. 20 pages in 2 days. And we want to know how many pages is she reading in 1 day. And let's look at May. Her situation is 35 pages in 3 days. And we want to know how many pages does she read in 1 day. Now, by the way, let's get back to the idea of who reads at a faster rate. So once we have the numbers to look at, then we'll talk more about how can you tell, because sometimes people have the right work, but they're not able to answer the question. All right, so same deal here where we're going to divide by the denominator. We divide by 2, that's going to give us the 1. And if we do 20 divided by 2, that's mental math. You should be able to come up with that, no problem. So that's 10 pages. 10 pages per 1 day for Amy. And in May's case, we're going to be dividing by 3 and dividing by 3. Now, if we're going to do the work off to the side here, that's going to go in once. Whoops, I put the wrong number there. Sorry about that. Now we're in business. Bring this down. That's going to go in once. And if we're going to use mixed numbers, we'll have 2 be the numerator and 3 be the denominator. All right, so what's May's rate? Her rate is she can read 11 2/3 pages per 1 day. All right, so when we say who reads at a faster rate, you have to ask yourself what would be true about the numerator. If they're reading at a faster rate, wouldn't they be reading more pages if they're reading faster? So doesn't that mean May is going to be our winner here for who reads at a faster rate? So if there's an answer space and you got to put somebody's name on it, we're going to put May. All right, so I think we're going to look at just a few more examples. Example number 4, an online music store offers 5 downloads for $6.25. Another online music store offers 12 downloads for $17.40. Which store offers a better deal? Once again, we're making a comparison between two things. So we have, we'll call this the 5 download store. And the other one, we'll call that the 12 download, just so we have some labels. All right, so over here on the left, if we show our proportions, we're talking about a certain number of downloads for a certain price. So how about we put the dollar first and the download second. All right, so we get this one, you get 5 downloads for $6.25. So we're going to figure out what's the cost per 1 download, right? What's the cost for 1 download? And over here, they have for $17.40, we get 12 downloads. So again, it's dollars and downloads. And we want to know what is it for 1. All right, so let's get out the calculator. So let me clear this from the previous one. Let's move this over. We're doing 625 divided by 5. And we get $1.25. So let's write that in right here so we have it. $1.25 per download. And for this one, we need to, in this case, we're dividing by 12 to get that numerator. So let's get out the calculator and do that. Let's move this over here now. Let's clear this. 17.4, which is the same thing as 17.40, divided by 12 equals, and we get $1.45 per 1 download. All right, so when we analyze the math there, which store offers a better deal? So would you rather pay $1.25 for that 1 download? Or is it a better deal to pay $1.45 for that 1 download? Well, wouldn't this be a better deal? So we would, if there was an answer space and we had to write something on it, we would say the store that offers the 5 downloads for $6.25 on the answer space. All right, so I think we might make another video for those who need more support, but I think that's a good start. All right, so look for video number 2 if you're still feeling like you need more support on this lesson.